Hello. So, I never see I'm very angry. I've seen stupid video like this. Right. So, we're gonna watch this video in this app, in this PWA. I guess this user doesn't even understand what is PWA. But, this is just junk, right? Bad dialogue. So first, he just put a big sign and say, you should handle bad dialogue, whatever. Now first, they can be handled is just wrong, because even Android doesn't support C++ exceptions. How do you handle exceptions when exceptions is not even supported? I don't even understand. I don't understand the logic. Okay, we're gonna review the code later. We're gonna watch this stupid video and watch this stupid comment, and we're gonna debunk them with actual facts, with actual logic. Plus, I'm gonna show you the actual implementation of exceptions and why fucking exception is so bad.
Hello and welcome to C++ Weekly. In this episode, I'm going to
use global speed to just make it faster because I don't have time to waste on this bullshit video anymore. It's fucking global speed.
Address a question or statement that I have seen a few times that basically says, because modern operating systems are willing to overcommit on memory, there's really no point for standard bad alloc to exist at all anymore.
I don't think the reason is just because of overcommit that is bad alloc to not exist, okay? This is just bullshit argument. Right. If you read this P0.76, is that even on this system, like people said, Windows, I don't know whether Windows have overcommit or not. It doesn't really matter. If you look at the Kopsada's video, we know something like point or Microsoft Word, right? You would think Word is something you really want to handle allocation gracefully, but they tried it. Just all the exceptions execution just crashed when the memory doesn't have over. It's smaller than 5 megabytes of memory. And they show that just there are no significant changes crashing Windows Mac and iOS. We're talking about a system that doesn't have overcommit, okay? But it still crashes. It's not a small memory, it's 5 megabytes. That's a huge memory, because if you talk about the 16-bit machines, it only has 64 kilobytes of memory. Here what we have is 5 megabytes of memory. But even that is a huge memory, okay? 5 megabytes is a huge memory. Think of the Windows XP kernel, whatever the kernel, right? The entire NT kernel was just that big. Back in Windows XP era, we only used 128. I remember I used 128 megabytes of memory. But see, the execution just crashes when when it's smaller than 5 megabytes, right? So then there's no static theory. So it's just come bullshit to say, oh, it's just because of that it crashes. It crashes slow. It's not just overcommit gonna causing these problems. Just a lot of environmental issue. Overcommit just one particular issue. Just a lot of them. Like if the environment doesn't support exceptions, how do you support exceptions? Through exceptions. You have GPU drivers that just cannot work when you don't have enough memory. It just crash down. The system just kill your process. It happens all the time. I don't even, right. Also, you need to understand, this is very important, right? Untested security exploit, and we can talk later.
I wanted to do an episode about this because I've brought this topic up with students a few times, and, well, my students have different experiences, shall we say. So, that's going to be the topic of this episode. Before I continue, I do want to remind you to check out the video description and see that there are links to upcoming events, links to more information about the sponsor, links to...
So this is exactly what we need to do, right? He's just looking for sponsors. We need to put him as sponsor block. We need to block him as sponsor, right? Block him. Whatever. I'm not going to
T-shirts and my books that I have published. So check out those things if you're interested.
See, all his videos doing about how to make money. You should never listen to these YouTube propagandists. Okay?
any of that. So I apologize for the much more simple...
Now first, we need to seek his desktop. His desktop is using fucking Ubuntu. Right? That's a red flag. Because losers he's using fucking Ubuntu. Right? See, Ubuntu. Right? So you know he's a loser when he uses Ubuntu.
than usual setup here, because I had to set up a few different environments to really be able to demonstrate the point here. I've created this experiment, and one of them creates filled vectors, and another creates empty vectors with lots of space reserved. So I am reserving size elements. And for the sake of this example, this is 1000.
That's the exact problem. You cannot randomly calling reserve on an arbitrary size. Right? Think of it, someone is giving you a size from the internet and putting the reserve. What are you going to do? Right? You're not even checking your input. So it's wrong in the first place. You're not even checking your input. Right?
1024 times 1024, which is 1 megabyte times 256, so 256 megabytes. But then I allocated integers here, so that's times 4 again. So it's basically 1 gigabyte per vector is being allocated. And for some context, this is a virtual machine that has 4 gigs of RAM allocated to it, and what is that? 1 gig of swap space. So what this does is reserve data, so basically 1 gigabyte per vector, without actually trying to write anything to this. And execute this, and we can see that it's, running this thing, allocating 1 gig at a time, until it reaches a bad alloc. And this number...
Another fear-mongering tactic, right? In fact, using Android, for example, another Linux distribution, when you allocate memory, you just kill a process. So the entire this mentality is just absurd.
That it has reserved is really big. What is that? 70 terabytes, I think, if I have that correct, in that order. And this is way more memory than this computer has. Basically, it is willing to reserve memory up to the point that it runs out of address space. That is what we are seeing here, which I know that our 64-bit pointers can handle way more than even 70 terabytes. So why does it fail there? You can look this up on Stack Exchange as just a really quick search here. But the point is that these things only have 48 bits or 42 bits of address lines, and then you might encounter some operating system specific limitations. And then this note of things like Linux allows 128 terabytes of virtual address space. So it's reaching limitations of both the physical hardware, which doesn't have full 64-bit address lines routed, and limitations of the operating system. It's willing to overcommit all over the place and just give me however much RAM I ask for until I attempt to use that RAM. And this is where things get a little bit wonky. In this version,
Each time I create the vector,
I am not just reserving the size that I want, I am actually filling that 1 gigabyte of data with data. I'm actually pre-filling the thing with the current iteration number is what I'm doing here.
when I execute this, you're going to see something rather strange happen.
This is a situation that is processed. So notice that once it reached the limits of how much RAM was actually available to this process, it actually killed the entire terminal. It killed bash. It didn't even just kill my program. It just died. This is a situation that is unrecoverable. In that aspect, this is true. On a 64-bit operating system, like Linux, and I think on Windows, on modern processors, there's a very good chance that when you actually try to overuse this memory, that you will simply just crash and there's nothing you can do about it. The operating system won't let you continue. If you run out of address space, on the other hand, you can get a bad alloc. Now I'm going to bring you to this 32-bit Debian instance.
See, he's just using a completely irrelevant topic now. He's 32-bit. Okay, he's talking about 32-bit now. Nobody is using 32-bit in 2024. Nobody. Right? Nobody. Nobody is using that on desktop.
Install that I set up quickly. This is just a modern version of Debian, 32-bit Linux, and I apologize for the fact that I am running as root. It was just the simplest thing that I did at the moment. I didn't even get X running on this particular virtual machine. I just have my tiny little test environment again. Now, what I have here is a little test program that knows how to allocate chunks in megabytes. I have this blocks data structure here that keeps track of all of the blocks that I have allocated, and I'm pre-reserving 16 blocks because I don't want the resizing of the vector that is tracking my memory use to, in some way,
He's just saying, wait, this can happen because of overflow.
get in the way of actually trying to do this example. I start out by saying I'm going to make a block of 1024 megabytes. So I'm allocating 1 gigabyte, and then I'm going to dump what that looks like. We're going to draw a little memory map of sorts, and then I'm going to free that block. And I'm going to dump this memory map again and show us that I don't currently have anything allocated. And then I'm going to reset my actual block tracker thingy here because I want to know the indices of the next things. So then I'm going to allocate 512 megabyte blocks of memory. Now remember, I'm on 32-bit Linux here. So this is going to be about 2.5 gigabytes. And at that point, I am reaching the limits of what is addressable in a 32-bit process on 32-bit Linux. Then I will dump that map again. Then I'm going to free up blocks 1 and 3. So I now have 2 more chunks of RAM that are 512 gigabytes available. The next thing that I'm going to do is dump this memory map again. Then I'm going to allocate 2 more 512 megabyte blocks. And we'll see that those actually go and fill in the last freed spots when we look at the memory addresses that are being used. We will look at this memory map again, and then I am going to free up those 2 blocks that I just created. And that gets us to this state where I've got 512 meg block, then a 512 meg space, and a 512 meg block, and a 512 meg space, and a 512 meg block. And then finally, what we will do is allocate 768 megabyte chunk of memory. And we'll see what happens at that point. And so we can see exactly what I said. In the first bit, it does that 1 gigabyte allocation, and we see the 1 gigabyte allocation that starts at, we can just look at the last like bit here of F010. And then I free it, and I have 0 bytes used, and then I create those 5 blocks, and I can see that I've used 2.5 gigs. And then I free the 2 middle blocks, and we're back to 1.6 gigs used. I allocate 2 more 512 megabyte blocks. We can see that those have filled in those spaces, and I'll try to put some arrows here overlaid to show where the memory got filled back in. Then I free those 2 middle blocks again, and I see that the...
He just showed a bunch of idiots argument. He's just want to tell you, hey, 32-bit integer overflow. That's everything he's saying. He's just telling all the bullshit. It's just saying, oh, 32-bit integer could overflow. Does he even testing this overflow of integer? It can happen, right? It just, if you multiply an integer plus, what are you going to do?
Last thing is the same as the second memory map that has been printed. Then I try to allocate 768 megabytes, and now I get that bad alloc. So it is possible.
Still, what are you going to do? When he talks about Linux, he doesn't count about Android. Right? Android is the biggest Linux distribution. He doesn't even care about that. Okay. Why is it a problem? It's not a problem at all. The machine doesn't have the capability of running something that you need to buy a better one. And this is ridiculous. I can just buy a 64-bit phone, right? Arc Linux phone. But no, just phone. I go to Walmart. The phone is an Android phone, RAX64, 64-bit. I cannot tell you for $40. For $40, okay? Now he's still showing you this stupid example where you can even get a better device by just go Walmart for $40.
So what we find is that it is very possible to get a meaningful bad alloc when...
The problem isn't whether it's meaningful or not. Is that, first, you have a lot of systems cannot produce this result for all sorts of reasons. Maybe they are not committed, or they mean they're not committed. They mean they're overflow, whatever. But they just don't support the exception handling, like Android. What can they do?
And we run out of address space. This is a very...
Right. The problem with it is there's no consistent behavior, and also all your logic of 32-bit. Why not just handling stack overflow? I allocate big array on stack, and it crashes. It crashes. Why not throw bad alloc for that? Why not throw bad alloc for stack overflow? You still, the logic isn't consistent, right? Your overflow logic, all your logic, in fact, stack is even less control because you don't even know how much size of the stack is. Compared to heap, at least theoretically you reach 32-bit of entire memory address space. You cannot do that with stack. You probably have very little stack. Even kernel stack, you will not see problem. Why not throw exception for stack?
real problem for 32-bit addresses.
Well, what problem? No problem. Just clear the process. Done. We're over. This entire thing is over. Just crash down. What's wrong with it?
Or smaller, in the case that you might be doing embedded development on an 8 or 16-bit platform, like...
This is the part of which is most ridiculous. Let me just explain.
In the case that you might be doing embedded development on an 8 or 16-bit platform.
First, 64-bit platform doesn't support exception handling. None of the 16-bit platform supports exception. None of them. Not a single one of them supports exception. What are you even talking about? What is he even talking about? None of these platforms support exceptions. They don't even support exceptions. Why do you even care about a bad alloc? They don't have exceptions. They don't have exception runtime. You cannot use exceptions.
Like AVR.
AVR doesn't support exceptions. Right? And that's part of the problem here. AVR does not support exception. If it doesn't support exception, what are you even talking about? He's talking about a platform that doesn't support exceptions to handle a bad app. See, he just fear-mongering technique, right? He's just saying, oh, maybe there's some imaginary platform, but that platform never exists in the real world.
And once you take into account memory fragmentation, you now...
So what are you going to do with memory fragmentation? It's not... What are you going to do with memory... Now you might say, well, just through... But your memory is fragmented. Can they still allocate any memory anymore? Even you recover? You might say, oh, just through exceptions, I'm just doing some cleanup. But even your cleanup code can through again, right? You can have heat allocation failure again. How do you, when you wrote destructors is a normal code. They allocate memory again. What are you going to do? Now you might say, we have this emergency heap. Bullshit. It's not a bullshit. It's complete bullshit.
Reach a point where you might not have a contiguous enough address space available to allocate the thing that you want. And this might even hypothetically be a problem on a 64-bit process.
Everything he's talking about is hypothetical. It's just fear-mongering technique, right? He's talking about something that completely doesn't exist. Well, in the real world, where he's using something, whatever, he's probably using Firefox, I don't know. But I guess you can't use exceptions in Firefox too. Whatever. Android doesn't support exception. Chromium doesn't support exception. Chromium is used by billions of people. Right? If that is the biggest problem that you had, they won't even use Chromium, right? Or LVM does the same way. Even the compilers themselves, like LVM, GCC, they use C++, they ban exceptions. Even the compiler folks don't use exceptions. Linux solvers hate exceptions. They say, oh, this is fucking exceptions is fundamentally broken. It's perfect correct. Nobody uses exceptions. You go this alpha fucking C++ kernel. None of the C++ kernel, because we don't, most kernels don't even reading C++ anymore because it sucks. Also, the embedded system don't accept generally sucks. Right, right. But he's talking about something that's completely, something that doesn't exist. All this platform he's talking about doesn't support exception.
That has been running for a very long time, and you have very fragmented allocation.
This is a problem. If you have very fragmented allocation, how do you even throw exceptions? Exceptions are allocated on a heap, right? Exceptions allocates on a heap. You try to throw exceptions when you don't have memory. It's just another problem, right? If fragmentation is so bad that you cannot allocate any memory, how can you even do anything? He has two problems here. First, he's not sanitizing input. That's the biggest red flag. Second, he's talking about something that is completely imaginary, doesn't exist in real world. But we look at Android. Android just do background process killing. You just kill process randomly. Nobody complains. We use phone every day. We don't use computer anymore. We use phone every day. Nobody complains.
allocations all over the place, then you need to do one more large allocation, and there just simply isn't a place to put it. Much less likely with 64-bit process than with 32-bit processes. And then you have the other thing that my students have pointed out to me. If you're using some sort of exotic resource like GPU or something that is giving you address space outside of main memory or perhaps shared memory or something.
He's talking about maybe there's some other memory you need to deal with. Does C++ even have this functionality to deal with these resources? It doesn't. Right? It doesn't even run on these platforms anymore because these platforms are freestanding. What are you even talking about? If you're running GPU program, you can't even run your C++ program on it.
Something else like that, it's possible that you actually get a bad alloc thrown that you...
Still, if you cannot allocate enough resources on GPU, you should just crash your GPU, crash your type program too. What's wrong with that?
You have to deal with in some way, or...
You have to deal with some way, which is crashing. Very simple, just crash your program.
In the case of some of my students who have done GPU work, they actually just get a null pointer back, and they have to deal with the fact that they tried to ask the GPU for more memory than they currently had available, and then they have to...
He's basically talking about we have try reserve. Right, that's what he's talking about. Which means you're just allocating memory randomly, just like I allocate a stack. I allocate stack, I put a big size, and put it in the alloc. Right, I just allocate big stack area on the stack, and the program crashes. You're just doing memory allocation without even doing anything. Right? You're just randomly putting data here. That's your problem. That's your bug.
To free up other data structures or do some sort of memory management with caching. And this is all stuff that's been true for a good while. So saying that dealing with an out-of-memory...
He's talking about maybe we can't do Android development anymore because it's not that reasonable. What reasonable? There's nothing reasonable.
Problem is something that's impossible, and C++ shouldn't even try to address this issue, is a viewpoint that comes from the perspective of specifically only working with main memory on a 64-bit operating system. If you're in any other system...
Only any other system. Kernel cannot use it, Android cannot use it, WebAssembly cannot use it. All my devices, basically they cannot use the exception. What are you even talking about? Why are you even talking about handling bad alloc when you don't even have these exceptions can be thrown? I'm not mentioning these problems, like saying you have this, right, just 4 lines of code. Right, they never throw exceptions, like title, whatever, but every function goes through now. The CEO can allocate memory, 100 can, all these things can throw exceptions now. How can I even test the code? How do I ensure the code is not has no bug? I cannot, because all the code you have 20, you see, you have 23. Have you ever even invisible 20 non-exception part of 20 invisible? Have you ever tested all of them? You cannot test it all of them because every function goes through now. The problem with alloc is that it proves every code. Right. Just like if you would do a plus b through starts with exception, even doing an integer plus these 3 exceptions, what can happen? How can we even write code? We're gonna lose exception. We're gonna lose all the exception safety at all. Because even by doing like allocate memory, I will try to write a class or you like Uniprot. I don't like Uniprot. Okay, as long as Uniprot through any exceptions by arithmetic inside, the program crashing. The program that it has these problems because it proves all the code path. Because every function can through it. So have you ever even tested this exceptional code path? You're not even testing your code.
situation, there's a very good chance that you actually have to deal with this kind of scenario.
Like I said, if you really have this situation, you have a very good reason, you say, I must handle this allocation failure. That's still out of the scope of what C++ bad alloc can do, right? So the entire logic is completely ridiculous.
In some way in your system. Well, I hope this was...
Some way doesn't mean using bad alloc. Some way doesn't using exceptions. Some way doesn't mean malloc. And in fact, I would argue even Linux kernel should just crash. Linus was totally wrong. Yeah, I just replied that C++ never serves the exception correctly. That you have SAJWJ, right? And itinium and all the bullshit. But think if they are crow, have you ever seen these issues on Android? Nobody cares. Your grandma doesn't care about you, right? You go to your phone. Nobody cares. They use Android phone every day. My parents use Android phone every day. So nobody cares about that. Nobody complains about it. Nobody. And what are you going to do? Also, another problem is that if you cannot allocate memory and you keep repeating it, your program will just stop. What are you going to do when the program stops? And I said, task manager can do it. What are you going to do with Android? How do you kill a process on Android? There's no way you can kill any process on Android. You cannot kill them. There's no way, because they are work orders, they're sandboxing, and each apps are sandboxed. So one process one application cannot access the memory of another, cannot kill another process, because they are in sandbox. That just can be ridiculous.
A meaningful episode, perhaps a little bit more esoteric or something than usual. Thank
as usual. Now we'll just do read some comments because I really replace this garbage. Okay. I have never seen anyone. I'm the guy who says I should exist. Default allocate should be no except. Yeah, the default should be no except. Why is not no except? Why does default allocator through exceptions? And also bad alloc shouldn't exist because it's a abstract machine failure. Even you want to handle it's a very bad way to handle that thing. Because C++ exception sucks. Right. And you have this logical problem of destructors and normal code allocate again, nothing bullshit. These people are just also funny. They are living in the bubble. They don't even understand we have this machine called Android. They don't even understand this phone. Right? They're just living in a small bubble. Where Android is the largest platform on the planet. And think of Android doesn't have exceptions. It doesn't support the exceptions. Right? What are you going to do? Does that mean Google shouldn't port Chromium on it? Google are not stupid, right? Google are not stupid. So if exception is handling kind of bad luck is that much a problem, which is it isn't, why Google doesn't care about it? Nobody cares about it. It's just fear-mongering. And another point I made the argument is that if you try to, I think this is entire fear-mongering of not crashing a program. What are you going to do? For example, what are you going to do when vector array out of index? Nothing you can do besides crashing. It's a program, but it must crash. Okay? If your system is not working, it must crash. It must crash. Okay. That's just to prevent further. Now people are gonna say, "Oh, crashing. We have this CrowdStrike situation." But think of it, if the CPU doesn't crash the kernel, what's gonna happen when they have memory safety bugs like that? You're gonna have basically remote code execution on everyone who installed that software, the little malware software, in the kernel, and it's actually in the kernel space. This actually just prevents being an actual exploit under these machines. Right? It's just, you need to reboot. Sure, it's still lost, But it's much smaller than someone just using your machine to do these things. Just completely ridiculous. It's just simply bullshit. Okay, let's just go and review why fucking exception is so bad. We're gonna see how GCC implements exceptions, or something like how LBM implements exceptions. This is how they implement exceptions. I guess nobody wants to reach garbage code like this. Nobody. See, also SGLJ, right? We have SGLJ. He's talking about 32-bit. What about WASM? WASM doesn't support exception, and I have lots of platform does support exception. Right. And it relies on, I guess, relies on hosted features, right? The wolf, right? I think it's SGLGO. The wolf. It should be unwind the wolf, right? Because it's the wolf. GTR. It needs thread. He's talking about embedded, but this needs thread, you know. Embedded doesn't have thread. These are all the junk you have with exceptions. Right, you need to first write C code. This is C code, just before using C++. C++ is not even a self-host language. It needs this stupid runtime with this stupid garbage, which is exactly the garbage here. It just blows your binary. It just blows your binary. For no reason. Even you want to use it, a lot of times you cannot. It's just a bad mechanism in the first place, but this stupid bullshit. Let's just go back to see fucking bad out and other bullshit. This is how they implement these bad out. Okay, you just go ahead and check the code. Okay, just totally garbage. We're gonna check several. This is the garbage you have with fucking exceptions. Okay. This is what you have. And you can disable the emergency heap too with it. Whatever. And see, we still have get expected. Even get expected get removed from the sender. It's removed. We still have get expected in the fucking exception. Just to through exceptions, you still have this garbage. This useless legacy BS. Legacy BS. And we'll see. See, this is the part I always complain. Right? Now let's see OPA. You just go and check it. Just so dumb. The entire bullshit is so dumb. Okay. Now we have so many new. Just for this new, you have so many methods. Okay. And it does loop. You know, that's how it does. It does loop. Okay? It does loop. Now, see, this is how your no through new is implemented. It implements with through new, which means you still need exceptions. Okay, if there are exceptions, it throws a no through new and using rapid and return no kernel. It's just complete bullshit, useless. It's just completely useless. Right? This function is completely useless, right? It calls through new, catch it, return your new product. But see, hey, use no through. There's no point even for, also this guy is talking about bullshit like PMR. What's the point even PMR? These people are just ridiculous. They're talking about PMR. What even the point? There's no point for this garbage. Personality. It's just junk. Okay, all these code are junk. Are junk code. That's the only thing you have to say about it. It's just junk. This is how your exception works. Then you tell them, hey, using exceptions when this platform doesn't even support these ABI functions. They cannot use the exception. And then you talk about, hey, using the exception in ABI. It's just completely informal. He doesn't even read code. He doesn't even understand. He doesn't understand anything. He's a moron. Let me check whether my streaming is still working. No, I don't. I think it should. It should. Let me see someone viewing the comments here. I do think probably. Yeah, that's exactly the problem. How bad it is? It's just like fear-mongering. This is why we have much more to fear than just this bullshit. Now see, I don't see any problem. Just see just compare my library compared to standard. What standard, how standard implements even allocation. Let's see malloc. We just see what malloc is. See, I just call malloc, crash, malloc, crash, realloc, crash, calloc, crash. Right, everything we've done is just crashing. Plus, we have this usable size. I can use allocate at least, which standard doesn't even support because of operating garbage. See, all my functions are no exception. All my allocation functions are no exception. The entire string class, you just go and check the string class. They are no exception. Oh, my microphone is noisy. Can you hear me now? I'm just using someone else's microphone. I just grab someone's microphone and use it. I'm not using my own here. Because I'm just so angry, I'm just so uninformed with these people how they are doing. Right. Now just go and check string. Just go and check string, okay? C+ standard even 3 exceptions for string view and an array. Okay, I think probably I need to do something to the microphone. Is that better now? Let me check whether some reduce. I don't know. Maybe you need to turn the microphone a little bit down. Let me hear myself. Let me check this out. LG, right? We have STLG. Oh, sorry. Talking about just terrible microphone. It's just a terrible microphone. Sorry about that. I'm just reducing the noise here with the one. Increase again. Okay. So what's the thought? What's your thought? I just disabled my microphone. Can you say something? Yeah. I'm gonna hear you. What's your thought? What's my problem? Even Android doesn't support exceptions. He's talking about all the platforms supports dialogue. And VEVR supports dialogue. Just terrible video. Never ever watch these people. These people are morons. They are morons. They don't even do any. He's probably a game dev. Yeah, he's a game dev. He's not even working in these actual environment that needs to do this work. He's not. He's just game dev. Game dev are retarded. Fine. Something like this. Is that okay? I don't think I can. It doesn't have this problem, you know. I just try to get off some noise reduction. I don't see any tower here. I've seen none of them. Sorry about that. It's just showing you, like you said, the C+ standards, the community doesn't care about anything. They only care about FMT garbage and other garbage. You know, they don't care about, oh, how we're gonna use it better. They just don't care. They don't fucking care, you know? Okay, I think that's about the streaming. Sorry about the noise. If you have issues, your comments and put your comments. I would like to have an open debate with the student guy. Okay? He doesn't know anything. That's all that I've seen of all these CPP gun guys, all these WG21 guys. They are just morons.